Okay, now here's example 7. It says consider the space P5 of polynomials of degree 5 or less and the map of F that sends a polynomial P of x to P of x minus 1. So think about this as this is an automorphism because it does map to itself, and you can see an example of this if you take, well, if you just look at this, what is this doing? It's moving all of the polynomials, right? So this polynomial is being moved to the right 1 unit, okay? But if you look at an example of, let's say, if you just take a bunch of parabolas, which would be definitely in this space, and let's say you take a bunch of parabolas that are centered at, let's say, 0, and let's say, well, here, let's just give an example. Do I have an example? No, I don't. Well, we could do this, where here we have, let's say, x squared gets mapped to x minus 1 squared, right? And of course, that's going to become, oops, x squared minus 2x plus 1, right? So we have a parabola here that is centered at 0, right? Where we have a parabola here that is where? Gets sent to where? So it's going to be 2, right? So the way this works is if you have, like, let's say a set of parabolas and they're a unit apart, right? And you're having a map where, hey, I'm going to shift each parabola to the right 1 unit, and it's just a string of parabolas. Well, what's going to happen is, well, you're going to move 1 parabola to the right, so the vertex is going to move to the next vertex. And so what happens is, after the function or the mapping is done, you have the exact same graph. It's indistinguishable, one versus the other. So if you look at it centered at 0, or if it's centered at 1 or -1, you wouldn't be able to tell the difference. And so that's an idea of how an automorphism works, is you're getting the same thing. Let's see, anything else I want to say about that? Nope, I think that's it. All right. Have a good day.